Rockpile Tutors here with a homework video. Today we're going to be finding the increasing and decreasing open intervals of a function. Homework problem sent in by a student. Number 9. Determine the increasing and decreasing open intervals of the function f of x is x minus 3 to the 4/5 times x plus 1 to the 1/5. All right, let's get this moving. So what we're going to do is we're going to recognize that whatever the function is doing, the slope of it is going to be 4/5 times x plus 1 to the 1/5. The slope of it is going to be the derivative. And so if we take the derivative, where the derivative is negative, it'll be decreasing, and where the derivative is positive, it'll be increasing. So we're going to use the product rule, and this will be x minus 3 to the 4/5 times d by dx of this, which is 1/5 times x plus 1 to the negative 4/5 times the derivative of x plus 1, which is 1. So I'm going to rewrite that as x minus 3 to the 4/5 over 5 times x minus 1 to the 4/5. All right. The second half, now we will add the derivative of this, 4/5 times x minus 3 to the negative 1/5. We're going to subtract 5/5 from the exponent, times x plus 1 to the 1/5. That is equal to 4 times x plus 1 over 5 times x minus 3 to the 1/5. Now what we need to do in order to figure out the end behaviors and around the interesting points is we're going to need to get this to a common denominator. What you'll notice here, this is to the 1/5. What you'll notice here is that by doing that, I'm going to end up by getting 5/5 of both of these terms on top, which I like. So what I will do is I will take this part of it and multiply. All right, I don't need to multiply by the 5 for my common denominator because I've got it in both of them. But this will need to be times x minus 3 to the 1/5 over x minus 3 to the 1/5. Right? This will be times x, man, I keep wanting to make it x minus 1. X plus 1 to the 4/5 over x plus 1 to the 4/5. And now you'll notice I'm multiplying these together. So my f prime of x will be, right, x minus 3 plus, right, this becomes x plus 1, so plus 4x plus 4 over 5 times x plus 1 to the 4/5, x minus 3 to the 1/5. All right, a lot of work there. Finally, we're going to combine this to 5x plus 1 over 5 times x plus 1 to the 4/5, x minus 3 to the 1/5. All right. All that work gets us there. Next thing we want to do after we've found the derivative is we want to figure out what the behavior of the derivative is, and wherever it is negative will be our decreasing slope, and wherever it is positive, it'll be our increasing slope. So we know we've got some critical spots we've got, we want to find where the 0 is. So that's where the numerator is going to be 0. So if I set 5x plus 1 to equal 0, minus 1, 5x equals negative 1, x equals negative 1 over 5. So let's call that right about there. And at negative 1, you can see that the denominator will be 0, and that's a no-no. So I'm going to have something happen in here at f equals negative 1. And similarly, at x equals 3, we blow up the denominator. So now let's try to figure out what these three terms will do at and near each of those areas. So here I'm going to have the 5x plus 1. I'm going to have the x plus 1 to the 4/5. And I'm going to have x minus 3 to the 1/5. So at x is less than negative 1, so way out here, let's think about like x equals negative 10, right? This is going to be a negative. This, x plus 1 will be a negative, but because I'm taking it to an even power, the 4th power, it's going to always be positive. And then this will also be negative. So the two negatives will cancel, and I will have a positive number. Okay? Then, right at x is close to negative 1, let's bring it from the negative side. Right, this is going to be a very small negative number. Again, doesn't matter because it's positive. So as x plus 1 gets very, very small, the number will go to infinity. Oops, let's pretend that just went straight up. And similarly, on the other side, it will also be a very small number. And so it'll come like this, and it'll get down to negative 1/5, where it hits 0. Now let's look at x equals 0, right? Because that's always nice. 5x plus 1 will be positive. X plus 1 will be positive. And x minus 3 will be negative. Okay, so that makes sense. So we're coming through to here. Right? And then let's see what happens at x equals 3. As I'm on the low side, so as x approaches 3 from the negative, from the 2.9 side, we end up with this being a very, very small negative number. So we will have positive, positive, negative, and small, which will drive that to negative infinity. So whatever happens in here, we end up down there heading toward negative infinity. And as x comes to 3 from the positive side, we're going to be positive, positive, and a positive small number, which will lead to infinity, and we'll do something like that going up. So now, in order to turn that, keep hitting that, in order to turn that into the regions that we're supposed to have, so the increasing regions is from negative infinity. So it'll increase, have a positive slope from negative infinity to negative 1/5. And then it'll be positive again from 3 to infinity. It'll be decreasing, right? That gets us up to here, and it'll be decreasing from negative 1/5 to 3. And that, if we go back to the problem, let's bring it down here. Matches our answer for D. Negative infinity to negative 1/5, and then 3 to infinity, and negative 1/5 and 3. And that finishes that problem. Hopefully you guys enjoyed it and learned something. And Throw comments, likes, and subscribe down below. And you can always find more at rockpiletutors.com.